Hey everybody, Dr. G here. Today we're going to do a couple lessons on just some Python basics and even start working with, reading in files in Python for scientific computing. There's a really great set of tutorials from the Molecular Sciences Software Institute. So I'm going to be working through the tutorials that they made. And then this way, as you're working through the tutorial, you kind of have someone there with you as you're working through it. So let's get into it. Today, we're going to be going over a tutorial, a Python tutorial from the Molecular Sciences Software Institute. It's a really wonderful tutorial that they've made, and I recommend this to everyone who's getting into, teaching themselves Python, with the intention of working with scientific data or engineering data. I think this is a really great place to start. So yeah, it's a really great tutorial. I'm just going to go through it so that if you're working on the tutorial, you can maybe have the video open while you work through it as well. And remember, don't just watch these things. You have to do it yourself to really make it stick as far as learning things. So this is the Molecular Sciences Software Institute homepage. If you go to Education, you hover over that, and then you click on Educational Resources. They have lots of stuff here, but we're going to start with this one, Python Data and Scripting Workshop. So I click on that one, and this is the one we're going to do. So as I said, we really need to work through it ourselves, not just read, right? So let's get Anaconda started. So I just started Anaconda. It's opening right now. So hopefully you've installed Anaconda on your computer. Anaconda is a really great way to get into using Python because there's different libraries used in Python, different functionality you can use in Python, and Anaconda kind of gives you the most popular ones all in one shot. So it's really great. I highly recommend it. So if you click on Jupyter Notebook, what that's going to do, it's going to open up a tab in your browser. And so this is not on the internet, right? This is on the internet. This is not the internet, right? This is just my browser showing me my own computer here. And then if I click on desktop, so it opens up a menu in your home directory, and your desktop should be one of the things there. And I have this async MolSSI here, right? That's where I've decided to put this thing. So this is just a folder on my desktop I've created for this project. Right? When you open this thing, don't just jump the gun and hit new and then make the make a new Jupyter notebook, right? You want to put it in a good place on your computer where you can find it later, because this is creating a file, right? We're interacting with things on the browser, but there's a file being created on your computer when you do this. So you want to first use this to navigate to a reasonable place to put it, something you can access through your desktop. Ideally, that's what I prefer. And then you click new. Python 3, and another tab will open. So again, there's this tab here, but if I open up, so there's a folder on my desktop called async MolSSI, right? If I open that up, this is there, right? I can get to this from my desktop. So this file, see, it's called untitled right now, untitled.ipynb, right? There's a Python notebook, or Jupyter notebook. Yeah, that's the file extension for a Jupyter Notebook. So if I close that, let's change this to, let's just call this, well, what do they call it? Let's call it Python Scripting. Python Scripting, MolSSI. There we go. Python Scripting MolSSI. So I hit rename. And now watch what happens. If I open up that same folder on, look, it changed the name, right? This Jupyter notebook that I'm interacting with in the browser is really living on my computer in this file right here, right? This thing is not on the internet, right? I can't stress that enough. It's a little confusing when you first start working with the Jupyter notebooks. Okay, so there's the file. We've created it. We don't need this anywhere. We can minimize that. So let's take a look at what they're having us do now. So basically what we're going to do, we're going to jump back and forth between the tutorial and this tab right here, where we're going to try out the ideas that, that they have recommended for us. So let's see. Let's do introduction. Let's see, what are we going to do here? Okay, so here they're telling you about Jupyter Notebooks, how you can run the cells. So we only have one cell here, and it's a code cell, right? Cells can be different types of cells. And if you want to run all of them, you hit Cell, Run All, right? So if there's a bunch of cells on this screen with code in them, that would run all of them. So that's what we're talking about here. All right, we're going to talk about variables and data types. Okay, so we can do some arithmetic, right? We can do 3 plus 7. 3 plus 7. Okay, so now if I hit enter, it brings a new line, right? But if I hit shift enter, then it executes the cell and it puts another cell below it. So remember, hit shift enter to do that. So there, 3 plus 7 is 10. Wonderful. So this thing is working. Now we have, okay, so how to set a variable name with a variable value. Well, let's copy what they have. See, this is the nice thing here. We can just copy their code. So if I do that, it's Command C on my computer. I can copy that, put that in a cell here. Command V, pastes it in there, Shift Enter. Okay, so this thing's run now. So what I've done here is on delta H, I've stored the value minus 541.5. So if I just run delta H down here, and actually I'll show you something. If I type DE and I hit the tab key, see how it's suggesting things? So there's delta H, so I can click on that. So that's like a shortcut, right? And if you get to the point where, let's choose one that's more unique. Let's go TE tab. You see how it finished writing it for me? I didn't type MP. I just typed TE tab. So this will save you a lot of keystrokes over your lifetime, right? If you, and believe me, they add up. So basically, once you've defined variables in your session here, if they have a unique name, you can just start typing them, hit tab, and it will automatically complete it for you. So you don't have to type the whole thing out. So that's really convenient. But so now if I type delta H and then hit shift enter, you see how I outputted the value? So with programming, we have this thing on the right gets assigned to the left, right? So minus 541.5 is assigned to delta H. That's what a single equal sign means, right? Later we'll do things with 2 equal signs, but if there's 1, that's what it does. It takes the thing on the right, assigns it to the left. So look at this line here. If this were a math equation, this would maybe be a little weird, right? Because you'd oh, never mind. We have a delta G and a delta H. It's not that weird. This right to left assignment thing gets a little weird when you want to overwrite a previous value. So we'll get to that in a second. But so basically, we're showing here that delta G is right. This is thermodynamics. Delta G, the change in enthalpy minus temperature times the change in entropy, right? Delta G, delta H, temperature, delta S, right? So that's what we're calculating here. And basically, we're saying that do this arithmetic, right? Subtract these, multiply these, subtract it from that, and then assign whatever this is to that. That's what we're doing. Okay. Let's see. I can zoom in a little bit and make this a little bigger too. Okay, so that's what we're doing in this part. And we're using a print function. So a print function is basically, like when I ran this, it kind of assumed that we wanted to print it, right? The developers that made the Jupyter notebook software kind of did that for us, but I could tell it to print. So if I tell it to print this, it looks about the same, right? But this can be very handy moving forward. So we'll use the print statement all the time. And what print is a function. So if you think about math, y equals f of x, right? If f of x is a function, I'll just type it. So if f of x is a function equals x, we'll say it's x squared, x times x, right? F of x equals x squared. So this is a function, right? And in a function, you give it something, and then it gives you something, right? Like when we think mathematically with a function, you give it something, it gives you something back. So if my function is this, I give it a number, it squares it and gives it back to me, right? I give it a 2, it gives me a 4. So that's how functions work. It's the same thing in programming. You give a function something, it gives you back something. You can define functions where you don't give it anything, right? You just run it and it gives you the same thing every time. You can do that. for now, think about functions. You give it something, it gives you something back. So this is a print function. And just like f of x, where we use parentheses, right? We use parentheses in math to show that something's a function. We do the same thing in Python. Right? So this function print that is built into Python, right? If you try to write a function and call it print, Python will not let you. That's protected. Yeah, so if you give the print function something, it prints it out to the screen. So pretty much what you would expect it to do. Okay, what are we doing next? That's more with the print function. Okay, assigning multiple variables at once. Okay, not every programming language allows you to do stuff like this. This is a very Python kind of thing here. So let's copy this code cell now. So if I copy this one, put that in here. I don't think we need this anymore. So I put that in there. We'll get rid of this as well. Just clean things up. And let's execute this now. Okay, so hang on. I'll re-execute this one because it's empty now. There we go. All right, so what did we do here? Here, we assigned more than one number at the same time. So it goes in the order you expect, right? Delta H is this one. Delta S is this one. And temperature is 298, right? So you're taking these three things and you're putting them into each one of these, right? In the order that they are on the equal sign. Notice that they're separated by commas. That's very important. You have to separate them with a comma, right? And if you're used to programming in other languages like maybe C, C++, this might look kind of crazy to you. Like, what? You can't just do that, right? But no, you can do that in Python. And the reason for that is Python is written in the spirit of readability, right? They want things to be super readable, and not really, part of readability is that things aren't any longer than they have to be. So in a lot of languages, this one line would be 3 lines of code. And once you get used to this idea that you're assigning more than one thing at a time, it's fine. It's not so bad, right? So you look at this, and okay, this is that one, this is that one, no big deal. Okay, and then in the end, we just use a print statement to print out the arithmetic that was done here to find our delta G from the enthalpy, the temperature, and the entropy, right? So that is that. Let's see, what else do we have on this thing? Okay, another really useful function that is built into Python is this one, type, right? So let's copy this. So let's find out what type does. Select, copy. So type. If I put that here and I run it, it tells me float. So what's a float? Okay, so that's a floating point number. So there's different ways to store numbers in a computer. All right, if you think about a computer, people say, oh, it's binary, it's ones and zeros. That's true, right? It's ones and zeros. So how do you represent a number that isn't 1 or 0? Right? There's different ways to do it. Sort of the simplest way with you could say all positive integers. You could say powers of 2. So 2 to the 0, 2 to the 1, all the way up to 2 to the 7 would be an 8-bit integer, and you just add them up. So you either turn them on or off, and that'll get you any number from 0 to 255, right? Where 0 you have all 8 bits turned off, and 255 you turn them all on. So these are different ways to store numbers, right? That's just one example of positive integers from 0 to 255 using 8 bits. But floating point, this uses quite a bit more bits. But anyway, there's other ways to store numbers, and if it says it's a float, that means it's a decimal, right? Just think of it that for now, since we're getting started. There's different ways to store floats, like depending how much precision you need, right? Because if you need to be really precise, then by all means use all those bits. But when you design a program, you don't want to just throw around memory that you don't need. So if something's going to be an integer between 0 and 5, maybe you shouldn't use a floating point to define that number, because you're just wasting bits. So anyway, this is the type of object this is, right? So this is a floating point number. So let's just do another one. If I say I'm going to define another type. So if I say my string equals, and then I put something in quotes, this is a string. So if I run that, and now I execute my string, notice how all I had to do was hit my tab and it finished it for me, right? I go Shift Enter. This is a string. Okay, so that's great. It outputted what it is, but let's use this type function. And again, this is another function that's built into Python. So if I run the type function on this, it says str, which means it's a string. So this is another data type, and string is basically, just think of it as text. It's just, it's kind of exactly what you give it, right? It means nothing but what you give it. So you can have a number, with 3.14159. There we go. So I can do that. It's still a string, right? So I put this number here, but because it's in quotes, it's interpreting this whole thing as a string. So if I just put this by itself, Python would say, oh, you must want that to be a float, right? So Python sets the data types automatically. Some languages don't do this, right? Like C, you have to tell something what it is. You'd have to say, oh, this is going to be a float, this is going to be a string, whatever. But Python basically guesses for you, and it can switch types for you. It has a lot of convenience to it, right? And nothing is free, so this can slow things down, the fact that it has this. But it's actually it's quite well built, so that a lot of things that you do, it won't really slow you down at all. But technically, there is a cost to that, of course, of having this dynamic typing, being able to switch types and just kind of have Python handle it for us. But anyway, so type will tell us the data type that you have. Okay. I'm moving from data types in the tutorial down to lists. Okay, so what's a list? Well, sometimes we want to be able to store more than one number, right? So here we've stored, delta G, we've stored a single string, or we've stored single numbers before, but now look, we can store multiple numbers. So here we have energy kcal, and we have 4 numbers here, right? So let's copy this into our Jupyter notebook, and let's run that. So if we run that, let's take a look at what's happening here. So a list, notice the square brackets here. That's what makes this a list. So this is how you tell Python, hey, I want to make a list, right? You put things in square brackets and you separate each one by a comma, right? That's what makes this thing a list. And so a list is an object. So Python is an object-oriented language where we're creating objects, and objects have they have information, and they have properties, and they have functions. So like if you think about a car as an object, right? A car has different properties, right? It has a color. Is it all-wheel drive or rear-wheel drive, right? It can have different properties about the car, but it also has functions, right? You can drive forward, you can drive left, you can drive right. There's different functions as well. And so it's the same thing in programming. You create an object, and the object is going to have some built-in functions, and it's also going to have some properties. So so this one, one feature of lists is that they know their own length, right? And this is something you cannot necessarily take for granted, but in Python, a list, it does, as soon as you define it, you can find its length using this length function, right? So we can get the length of this thing. So len, that's what this function does, is you pass it an object, so we passed it energy kcal, and it gives you back a length. It gives you back what the length is. So in this case, we take that value and we store that in energy length, right? So if I just copy this and I run energy length, paste, execute, that's 4, right? But look, if we include it in a print statement, we say print, here's a string, right? See the quotation marks? You can use single or double quotes, and then a comma, and then energy length. So it printed out both of these things. The length of this list is 4, right? There we have it. So we could play with this, right? We could add another number in there, right? 44, run that. Now the length of the list is 5, because I have 5 numbers in here, right? So you see how this number went up to 5 here. Let's put it back just so that they're examples. See, now we're back to 4, right? And energy length is 4. Let's see here. What else do we have? Okay, so lists, you can pull certain elements from it, right? So for this one, we have print. Let's just copy it, right? print the first element of the list, right? By the way, this is a comment up here. See how there's a pound sign? What that does, that tells Python, this is not code, right? Don't run this as code. I'm just writing a note to myself or to other people or whatever, right? It's just a note. So if I run this one, okay, so we have energy kcal and we have a 0 in square brackets. So if we put these square brackets here, it's selecting this first element here. So important thing for lists, the index. So the index is what we call like how you refer to different parts of it. So if I say index 0 is the first one, then it goes 1, 2. So you start counting at 0. So 0, 1, 2, 3. So if I put a 3 in here, ask yourself, what are we going to see? 42.1. There you have it, right? So if you want the fourth element here, you refer to it as 3 because the counting started at 0, right? So that's an important thing to remember with Python. Okay, what else can we do? Okay, this is interesting. So here we're going to do a unit conversion with the second element. So let's copy this one and run it. If we run that now, we've got, what did we do here? So we said energy kilojoules. So we're taking this one thing, right? This was a name that we gave it, right? We could have named it Frank, but instead we're naming it energy kilojoules. And by the way, don't try to be too clever with your naming of variables, right? So if you're tempted to give them all silly names, I advise you not to do it. I enjoy silly things, but giving your variables silly names that are not informative is really bad. You always want to give things informative names because later it'll drive you crazy. So just trust me on this one. Name things informative. Give things informative names. And if they're both funny and informative, then great, but they have to be informative. Okay, so we have our energy kilojoules here. We assign this. So what do? We said energy kcal, we went 1. Well, energy kcal is this, right? This is energy kcal, 0, 1. Okay, so we're taking minus 2.7, minus 2.7, and we're multiplying it by 4.184, and then we're printing the result here. So what this is demonstrating is that I can pull part of a list out and do some math with it. So that's pretty much what they're demonstrating there. Okay, what if I want to pull out more than one number? Okay, well, let's see here. Did we define short list? I don't believe we had that one. Okay, so for this one, let's see if we can find short list on here. Well, we'll make our own. So if you have some sort of list here and you want to take multiple numbers from it. Oh, here we go. They have short list here. Let's copy that. And let's paste it here. And let's run it. All right, so what did this do? Well, let's just output short list. So short list, and notice, right, I just hit SHO, tab, and it finished it for me. Now shift enter. And what did it do? We have minus 13.4 and minus 2.7. Well, we went energy kcal 0 to 2. Okay, 0 to 2 of energy kcal. Energy kcal is here, 0, 1, 2. These three numbers. Do these three numbers, okay, they don't match, right? We got 0, 1, 2, and this goes 0 to 2, right? There's a colon going from 0 to 2. It went, but we go 0, 1, 2. Notice that the one that is indexed at 2 is not included, right? Well, the first two are there, but not the third one. So this is another important thing to remember for Python, is that basically we're saying we want elements from 0 to 2, but not including 2. So basically, we want elements starting from 0 and less than 2 is really what this is giving us. So this is another really important thing to remember with Python that I think people sometimes can get confused when you're just getting started, is that if you take a slice going from 0 to 2, you're going to get element 0 and 1, but not 2, right? So you do get the 1 in the beginning, but you don't get the 1 at the end. So just remember that, all right? Another just important thing to know with Python. Cool. And so another way you can kind of remember this is that this number here, that's how many things you're getting, right? If you're starting at 0, right? I'm going from 0 to 2. I'm getting 2 things, right? But I start the counting at 0. So I'm getting element 0 and 1, but not 2. All right, that's probably enough of that. So let's see, what else do we have? Okay, loops. Okay, so now let's move on to loops. Now, it's a common thing when you're writing a computer code that you want to do the same thing a bunch of times, right? This is sort of a fundamental thing in computers, right? If you're going to want to add up a whole bunch of numbers, it's nice to not have to do that by hand. Just get a computer to do it automatically for you. So that's what a loop is, and there's different types of loops, but a for loop is the one we're going to start talking about. So here we have just sort of a general way of thinking about it. This is kind of like what we call pseudocode, where like, you wouldn't try to run this, but it gives you an idea of what's happening. So we say for some variable in some list, colon, new line and indent. That indentation has to be there. So another unusual thing with Python that is not in a lot of other languages is that the spaces matter. So basically, this indentation has to be here. What's cool is that if you're working in a Jupyter notebook, it'll do the indentation for you, and I'll show you that in a second. So let's work with this one here. Let's see, for number in energy kcal. Let's copy that for loop. Copy that. Paste it here. Let me zoom in a little closer too. Here we go. All right. So now we've got this this for loop. Let's just run it and see what it does. Okay, cool. So what this does, we're working with our energy kcal list that we've already made. Where is that thing? Energy kcal. Here it is, right? We made this thing. We've already defined that. So we've defined that and we've executed this cell, right? If we had pasted this in there and didn't execute it, Python wouldn't know that this was a thing, right? It only knows that it's here because we executed this cell. Okay, so energy kcal, it's these 4 numbers. Great. So what are we doing in the for loop? Well, we're saying for each number in this loop, in this list, do this. We're gonna define some variable kj, and we're gonna assign to that variable the number multiplied by 4.184, and then we're going to print out kj. So that's what the loop did. So let's talk about what had to be here and what were options, right? The word for that's the keyword to tell that Python that you want a for loop, right? So that has to be there. And notice how the font is a different color. It's this green color. It does that automatically, right? So if I type for, see how it does that? And this is another just really great feature about Jupyter notebooks. They're really wonderful to work with. Okay, so you say for number. Okay, now this number could have been anything. We didn't have to call it number, but again, name things in an informative way, right? Do yourself a favor. Trust me on this one. Use informative names every step of the way, all the time, right? So, okay, say for number in. So this is also, see how it's green, is also a keyword. That word in has to be there. For number in, and then you have a list. And it doesn't have to be a list. You could give it an array. There's other things you could give it, but one of the things you can give it is a list. And then we have this colon here. That colon has to be there. The new line and the indentation has to be there as well. So what I'm going to do down here, I'm going to, let's say that I hadn't copied this from somewhere. I'm going to type it out myself. And let's say I'm going to say for num, because let's say I'm fine with num. I know that num is a number, right? And I say in, see how it makes it green. And then I want to do this energy kcal still. So en energy. So I hit the tab key. ene could be more than one thing, so it shows me all of them. I choose the one I want. I just hit enter there. Now I hit a colon, and now I just hit the enter key. And notice how my new line is already indented, right? Because basically Jupyter knows that this is a Python cell. I'm running Python. So it says, well, I know what you want. You're going to want a new line with an indentation. So it does it for me. So just type the colon, hit enter, and you're good to go. And then I'm going to show you that we could actually do this in one step if we wanted. So I could just type out print, right? Print is a function. and we're going to print out number times that. But remember, I called number, instead of calling it number, I called it num. So let's make that match. So if I run that, then it does the same thing, right? So what I'm showing you here is that this name is a choice. This is the list or other object that you want to iterate over, and then inside the loop is what you're going to do. So anytime you're referring to the numbers in energy kcal, so let's just show those real quick. That's these numbers, right? So basically, as I go through this loop, when I say for num in energy kcal. So that means go through this loop and take each one of these one by one. And when I take one of them, I refer to it as num. That's kind of how you can think about it. So if I'm inside the loop, I take this one. First num is equal to minus 13.4. So I take minus 13.4 and multiply it by 4.184. Then I go back to the top of the loop. Now num becomes this number, right? So I keep doing this, that num keeps taking on these new values until I run out of values. And then I'm at the end of the loop. So that's what a for loop is. You can do a bunch of things. You can do something a bunch of times, right? To elements that are stored in some sort of thing like a list, some sort of object like a list. Alrighty, so now we've done sort of your basic for loop, right? We've done just a for loop that goes through one list and outputs something, right? According to the elements of that list. But what if we want to do something where we actually want to store something new, right? Let's take a list and then use a for loop to create another list. Well, let's try and run this loop. That's what this one's doing here. So I copy that. We paste this one in. Uh-oh, what happened? Let's see here. Energy kJ is not defined. Well, if we look back at the tutorial, they did this to us on purpose, right? They're testing us. So they said, okay, see if you can figure out why this isn't working. Well, if we just read the error, see how they have this nice little arrow here, right? This is nice that Python does this. It points to this line. It says this is the problem, right? The problem's here. The name error, name energy kJ is not defined. Okay, so basically, we have this energy kj object, and we're trying to use the append function from that object. But we never told Python that energy kj is a list, right? Append is a function that lists have. So, what we can do, why don't we first define this thing as a list and think, what is it that makes something a list? These things, right? Square brackets. So if turns out you can define an empty list like that. So we'll just say energy kj equals this, and we just put square brackets so that Python knows, hey, if you see this thing, that is a list. Now let's see if it runs. Okay, cool. So now it looks like it worked, right? So now it was happy with this, right? Energy kj, we tell Python this thing's a list, and inside of this loop, what we do is we take this list function and with this list object, which has a function called append. So you use this period here, right? You go energy kj dot append, and then what are we appending? We're appending kj. What's kj? We define it on this line, right? So the for loop is taking every number in energy kcal, and we multiply that number by 4.184, and then we append it to energy kj, right? So this list in the end has 1, 2, 3, 4 elements, right? And energy kcal has 4 elements, right? So that's what it's doing. It's going, we're calling like numbers like our placeholder, right? So first number is this one, and then we multiply it, right? And then number is this one, and then we multiply it, right? And then each time that's being stored in kj, and then kj gets appended to energy kj. And then in the end, we just print it so we can see what it looks like. So cool, now that's working. Let's see what else we have in the tutorial. Let's see here. Okay, there's where they fix it. Okay, logic statements. So another thing you can do in programming is logic, really, really important operations for programming. Let's take a look at this example. So this one they define an empty list here. Then we have a for loop. Okay, so far stuff we've seen. Now we see a new keyword, right? If. And notice it's in green, right? Python makes them green if that's like a protected word. Like you can't define something that you're going to call if. Python won't let you. That's protected. So now we're saying if the number is less than 0, then append it, right? So if the number is less than 0, append to negative energy kj that number. So let's see what happens this time. Let's run this thing. We run that. Okay, so now we see we only got the negative numbers, right? If you compare it with this one, right, here we have negatives and positives. Now we've only got negatives, right? So yeah, there you have it. So, or we could go the other way, right? What if, just to try it, right? And I encourage everyone, like as you're working with this tutorial, if you're just curious, like, oh, I wonder what happens if I do whatever you're thinking, just try it, see what happens, right? Okay, cool, we got positives now. And you know, when you start trying stuff, you're gonna get some errors, but you know, who cares? You know, you get used to seeing those things when you've been programming for a while. You don't get too disheartened by error codes. You know, if you see the same one for long enough, yeah, after a while you get mad, but you know, you do get used to it. All right, what else do we have in here? Okay, so we have other logic operations, equal to, not equal to, right? Greater than or equal to. So let's look at these equal to ones here. Let's say, let's copy one of these here. Let's do this one. So if I copy that and I say if the number is equal to, remember I mentioned double equals earlier, right? Here we have it. Let's see if this works. See that? Now it checked if that number is equal to that. So this time it's cycling through all of these, but it only stores it in negative energy kj if it's equal to exactly that. And this one happens to be, so then it gets appended, right? So there we used equal. Now let's do not equal, exclamation point equal, right? Now if I run that, now look, the opposite happened, right? So now everything except for this got added to the list, and there you have them. They're right here. So these are also important. These logic operations, we call these, and you can use and, or, not. Let's do another one. Let's say if the number is not equal to this, and let's say if number is not equal to that, let's say that, let's put them in parentheses just to make sure that they get evaluated in the right order. So let's say and number, let's say it's not equal to that, and we say that it's less than 0. Less than 0. If I run this, what happens? Okay, cool. So now we said, as we loop over energy kj, remember this is energy kj, right? This is what it looks like. As we loop over that, we're going to append it to this if the number is not equal to this minus 56.0656, right? This one. We're going to say if it's not equal to that one and that number is less than 0. Right? And I put these two things in parentheses so that I can be sure that everything gets evaluated in the right way, right? And it might run without them, but you know, I find when I do logic statements like this, I kind of go a little nuts with parentheses just to make sure that things are going in the correct order, not getting grouped the wrong way. So cool. All right. So now we've done some logic operations. Another big part of programming in general. Let's see. Okay, it looks like we are at the bottom of this exercise. So we've made it the whole way through. Let's see, what is this one? We've made it through the introduction. So cool. That brings us to the end of the introduction. So let's take a look at the next one. Alrighty, so we finished the introduction. Now let's go back, and the next thing they want us to do is file parsing. So we click on this. All right, so file parsing. You know, clearly working with files is high priority, right? They've made this the second thing you need to learn for the Molecular Sciences Software Institute. So, you know, clearly working with files is really important to using Python to do this type of work, right? Really any kind of scientific computing, being able to work with files is really important. Read them in, write out different files, super high priority thing. So this is actually the second thing we're going to do. And I noticed that they want us to work with a file called ethanol.out, and I have not yet downloaded any files from the tutorial. So I think, we may have jumped the gun a little bit here, right? We went straight to introduction, but there's actually this setup. So let's go to setup real quick. And we see, download the files needed for the lessons here. So I'm going to click here, click that. It's downloading. And now if I show this in the Finder, this is in my downloads here, right? So now this is a really important thing. This file needs to be in the same directory. It has to be in the same folder as where I saved the Jupyter notebook. All right, so I'm going to open that up again. So I just opened this up on my desktop, right? It was just on my other monitor. But so I opened this up. This was on my desktop, this async MolSSI, right? This directory right here, this folder lives on my desktop. So I opened that up. That's where this lives, right? Remember I showed you as we made the Jupyter notebook, this is here, okay? So I've recently read that this is kind of a generational thing. A lot of younger students now are used to computers that you're protected from having to know where your files are, right? The developers keep making everything easier and easier to use. So see how I moved the data file from the downloads, and now it's in the same directory as this, right? And now I'm going to double click this to unzip it. Okay, cool. Well, yeah, so and now I don't need this anymore. So now I have the data that I need to do this project. So this is really important that we have this. So if we look in here, yeah, so out files, and I think it was ethanol. I think this was the thing we're going to end up using here, right? So these are our out files, and this directory is here, right? And this isn't like, so knowing where your folders are, things like that, it's not an old-fashioned thing. This is still being done, but if you haven't had to worry about it before, it's just because your computer's doing it for you. There's apps taking care of it for you. But doing scientific computing, we have to worry about these things ourselves. So this might be a little bit of a new experience for you, but it is very important. You have to know where your files are. So, okay, so this is the Jupyter notebook, right? This Jupyter notebook right here that we've been working in and typing stuff, and we can save it, and we're doing things. We look at it in the browser, but it lives here, right? The actual file is here in this directory that I put on my desktop. And then within that directory, so I open on my desktop, I click this folder, this opens up. Now I put this data that I downloaded here, right? So that's where that is. So we should have everything we need to do the tutorial now. So, okay, so let's open up, let's go back to the instructions here. Okay, so this was where we downloaded it from, right? This was the setup page that was set up. Now let's go to file parsing. So let's at least get this one started here. So let's see, file parsing. What do they have us do first? Okay, so one thing we need to do is import OS. So import functions, I don't believe we've used import yet, have we? We have not. Okay, so import is a really important function to know how to use in Python. I'm going to paste that there, and then I'm going to execute it. So that just ran. So what I did right here, I imported a library. This is called OS for operating system. And so what libraries are in Python, there's different functionality that you can have in Python. And basically, if there's some task that you're going to need to be doing, and maybe it's a really common task that lots of people need to do, like let's say taking the cosine of a number, right? If we were so motivated, we could write our own cosine function that you give it a number and it outputs the cosine. But that would be kind of silly because there's a bunch of these floating around already. So we might as well use a cosine function that other people have written. And so that's why we import libraries to do things like that. And okay, so why doesn't Python have all of these all the time? Well, these things aren't free as far as the memory on our computer goes, right? So if you loaded every library ever made for Python, most laptops could not handle that. Right? It wouldn't have enough RAM. So you always have to cut it off somewhere. All right, what are you going to include? So yeah, this might be your first experience with importing a library. So we're importing OS, which is a library that basically it allows Python to know something about the operating system. so that if I give it a pathway to different files, like we just talked about how I go to the desktop here, and then I open this folder, and then I can open that folder, and then open this folder, right? I can find files through a path of directories, right? Basically, if you have a Windows machine or a Mac OS or Linux, they can have slightly different ways of storing the directories. Like there could be a / instead of a \, like things like that. So by using this this OS here, what this does is this allows us to write just general statements in Python that will work on any computer. That's the idea, is that if I hard coded that for what works on a directory system on a Mac, and I have some / and somebody tries to use it on Windows and it won't work because the slashes are going the wrong way, that's annoying. So by using the OS, by using this OS library, it allows us to write code that'll work on either machine. Okay, so let's see what we're supposed to do. Okay, so we import the operating system. Okay, now we go ethanol file equals OS path. All right, let's try and copy this thing. Let's see if it runs okay. Let's run it. Let's see, do they put it together? They put it in the same cell. Well, I'm going to put it in a separate cell. So if I put that here, run. Okay, it worked. Let me zoom out a little bit so you can see the whole thing. Okay. So this is ethanol file equals OS. So this is this library. And then within that library, we're going to access part of that library with path. And then from there, we're going to take a function called join. So now we're going to use this function join. So this is join data out files ethanol.out. And this entire thing, remember, things get assigned from right to left. This entire thing gets assigned to ethanol file. So now when I print ethanol file, this is what it looks like, right? Data out files ethanol out. This is the file path that leads from data out files ethanol. Where is it? Ethanol. There it is. Ethanol.out, right? So this is the path. This is how it works. And because I happen to be working on a Mac right now, it has these with /. So if you're working on a Windows machine and you just ran the same thing, this output might look different for you. But that's okay. That's exactly what OS is supposed to do for us. So right now what we've done is we've established a path through the directories, right? A file path that leads to ethanol.out. Right, so this is what I was saying, how we need to know where our files are if we're going to do scientific computing, right? We're taking our abilities as computer users to another level here. Right, okay, going back. All right, what's next? What else do they want us to do? They want us to read the file. Okay, let's run this thing. So here we're gonna. Okay, this is cool. So we're gonna open the file and then we're going to read lines. So let's copy this. All right, copy. I paste this right here. Run that. Okay. So what have I done? So we call something out file. We're going to call this thing out file. We're going to use a function, a Python function called open, right? This is just there in Python for us. See how it's in green. Open ethanol file. Okay, that's this, right? Remember we defined that here. Open ethanol file, and we have in quotes, read. So you can open files in different ways depending what you want to do. If there was a W there instead of an R, it would be for write, right? Read or write. So you can open files in different ways when you're doing programming here. So we're going to open it as to read it. So open ethanol file as read, and then this action of doing this, we're calling that out file. So now we've created this out file object. And remember, objects have functions, right? They have properties and functions. Remember, just always think back to when you forget what an object is, think, okay, a car is an object. It has properties like its color, etc. And it has functions like it can drive forward, it can drive in reverse, right? So same idea here. So out file is our new object. And if we hit the out file dot, and then we can access functions that this object has. So read lines is a function of one of these open objects. In fact, if we want to check out the type, let's check it out. Type, what is it called? Out file. Out file. Execute that. See, it's an in-out text IO wrapper. So that's what this object type is called, right? So it's an object that's good for data going in and out, right? That's what the IO is there. So cool. So that's what we have here. And now we've done outfile.readLines data. So what is this thing? Well, let's check out its type first. Data. It's a list. Oh, okay, we've worked with lists. We know list. Let's just try executing data in this cell and just see what it spits out, right? Whoa, look at all that. So there's a bunch of stuff in here. Let's take a look at a little bit of it here. Let's scroll around here. Open source, ab initio, electronic structure package. Wow, okay. So there's all kinds of information here. So this ethanol file here, let's see, ethanol.out. This is the output from some sort of, chemistry software here, right? Look at all this information. So that's what's in data right now. And it said this thing was a list, right? So remember, we can look at one element of a list at a time, right? So let's look at the first element. What is that? It's just this new line abbreviation. That's what that means. Let's see here. Let's take a slice of this thing. There we go. You see how I can take slices of this thing. So what we notice here is that each element of this list appears to be a new line, right? So you see how like it has like this symbol, this new line symbol, comma, then all this stuff, comma. And all of them are, each of these lines is in quotes too. Did you notice that? So it looks like each of these is a string. So it looks like we have a list of strings. And you know what? We can check on that. Let's check on that as well. So let's do, so if I take, let me just take, let's see, 1, 2, let's take the third line here. So remember, this is the number 2, right? Because it goes 0, 1, 2, right? To get the third line. Okay, we got that thing. So now I've taken the third element of this list called data is that. Let's see what type this is. So I took number 2, but I can take the type of that using the type function. So let's see what this thing is. It is indeed a string. So our intuition was correct, right? So now let's just do one more thing. Let's look at this. And now let's go check out this file. So this file, where is it again? It's in data, out files, and that's ethanol out. So data, out files, and ethanol.out. I'm going to open this thing as a text file. So I'll use a text reader that I have here. It just comes with the computer, text edit. Open that up. This is what it looks like. So if I look at this and I look at this, cool. All right, so it read in the file. Each line is a string. So that's what it did for us. I can close that. We're done with that. Okay, cool. So that's what data's given us. I'm just going to delete that, execute the cell to get rid of everything. Great. So now let's see what they want us to do about this. So we have this data loaded in here now. And then when we're done with it, we want to close the thing up again. So the reason for this is, remember, we don't want to waste memory, right? So by having this thing open, this thing is being stored in our RAM, right? We're using up memory on our computer to hold everything, to hold this file open, right? This object here is still hanging out, wasting memory, right? But we've already done everything, right? We've already read the lines. That's what we wanted to do with it. So after we read the lines, why don't we close it? So outfile.close will then close the file because we've already done that. So now let's close it. All right, so now that file's closed. Now what do they want us to do? Okay, cool. Let's see here. What else are we going to do? Okay, so this is another way to read the file in. So this is another option we could have done. What's cool about this is I think this is the one where you kind of don't have to remember to close it then. So you can say with open this as out file. We can do that, right? So this is something else we can do. So let's run it. Let's see what happens. So if we run that instead, you know, I'm going to turn these into comments for the time being. There we go. And then I'll comment this one out as well. And then let's put this stuff here. So it says with open. So right, we had this here, right? Open ethanol file R, and we said out file equals. Well, here we say this name out file is here now, and we still have open. So you see how this is kind of the same thing, but we've just moved things to different places. So instead of saying open this thing equals this thing, we're saying with opening this thing like that as out file. So we're saying like create that file IO object thing, and we're going to call it out file. So just like we did before. But then while that's open, then do this stuff. Do this thing. Well, okay, that's what we did here. So what this does it in one shot, and then we don't have to remember to close it. Like if we know that when we open this thing, this is all we want to do, this is a really great way to do it. So we've saved ourselves a line of code, which, you know, every line you can save, they add up. And then also like this kind of like, we don't have to remember to close the file now, right? Because the thing will keep running. Like if let's say I forgot to do that, I wasn't paying attention to the directions or whatever, this program would still run just fine, but it would be wasting RAM. So you can make these mistakes that just kind of silently waste RAM on you, right? And then these things add up, and then your fan starts running real hot, and it's running like crazy, and your computer gets hot. So yeah, so this is kind of nice that way, that you kind of can't forget to close the file then. So that's pretty cool. Okay, so we've done that. And you know what? Let's take a look at data. Let's look at the first 11 lines of this one. See what that looks like. Okay, it's the same thing, right? So it did work. It did the exact same thing, but in one line less. And now we have the added benefit that we won't forget to close it. So let's see what else we got. Searching for a pattern. Okay, this is cool. So let's see here. Okay, let's try this one. I like this one. We'll copy this example, put that in. So now if we have this, let's read it before we execute it, right? We want to know what it is we're doing here. So we're saying for line in data. Okay, so this is a for loop that we're looping over a list called data, right? We just made this list here, right? Remember we checked its type earlier? It's definitely a list. So for each line in data, so as I go down each element of the list data, I'm going to call the element line, right? So when I want to do something to that particular element as I go, repeatedly with the for loop, going down the line with it, we're going to call it line. So inside of the loop, we're going to call the thing line anytime we want to do something to it. So, okay. So if final energy is in line, then we're going to do this. We're going to say energy line equals line, and we're going to print the energy line. Okay. So basically, we're looking for... So remember, each element of our list is a string. And this in function can check a string and see if a smaller string is part of that string, right? So like if one of the elements of this list was like final energy is super cool, right? That was one of the elements. That, we would get that line. It would pull that line because final energy is part of it. So let's run that. Let's see what happens. Okay, final energy is only in one of the lines. And there it is. So basically, you see how that big text file has all kinds of information in there. But what if all you wanted to know was the final energy, and you happen to know that with this type of output, right? Because if you've been working with the same type of simulations, you kind of know the format of the output. Let's say you know that final energy only shows up when you have the final energy in that line. So this is a really quick way to pull that out of the file. So that's the value of this, is that you can loop over the data and just check to see where the word final energy shows up. And if that final energy does show up, print the whole line, and then we can see what our final energy value is. All right, folks, I think I'm going to leave it there for you. So we've done a lot of the introductory Python lessons, and we've done a lot of the file parsing lesson. We skipped around a little bit, so I encourage you to really go through there and read everything. Make sure you really get everything you can out of these tutorials, because like I said, they're very well done. And I'll probably do more videos like this that just kind of follow along with the tutorial as well. So, all right, I'll see you next time.